Wait, Maddie. Nako. Okay, sound check. Am I audible? Can you hear me clearly? Can you hear me? Clearly? Okay. Okay, so for this morning, we will try to finish about subgroups and cyclic groups. And address some of your questions on generators of a group, how to determine subgroup of a group, and so on and so forth. Okay, so let's review the properties of a group. Again, 4 properties must be satisfied in order for a set with a binary operation to be considered a group. So, a set G with the binary operation, let's say circle, is a group if the 4 properties are satisfied. The set is closed with respect to this operation. Okay, the operation circle is associative. And then number 3, there exists an identity element, i.e., such that A circle E equals E circle A equals A. Okay, so when we operate on, or when we take one element of the set and operate it with the identity element, it should yield the element of that set, A. Okay, this is for all A in G. And number 4, there exists an inverse. We shall denote it as A raised to negative 1 for every, okay, please take note of this part, for every A in G, such that A times A inverse is equal to A inverse times A, and that should yield the identity element E. Otherwise, if there is even just a single element of that group which does not satisfy number 4, then right away we can say that group is, that group is, or should I say that set is not a group with respect to the operation. For example, your set of integers modulo m, modulo m, for example, z sub 5 under the operation multiplication. Why is z sub 5 under the operation multiplication not a group? Okay, let me write that down. Your set of remainders upon division by 5, 0, 1, 2, 3, 4. Okay, with respect to the operation multiplication modulo 5. Okay, so if you check on the 4 properties, okay, closure is satisfied. Okay, when we multiply any of the, any 2, we take any 2 of these elements, the result is a member of the set. For example, 3 times 4 modulo 5, that's 3 times 4 is 12. 12 modulo 5 is 2. So it's there. 2 times 3 modulo 5 is 1. So it's there. Closure property is satisfied. And so with associativity, by the associativity of ordinary multiplication, okay, so property number 2 also here is satisfied. However, okay, also property number 3. So let me just list down as fast as I could so we could move on to the next. Okay, clause, yes, closure property is satisfied. No doubt in that. Number 2, okay, multiplication modulo 5 is associative. Reason here, because of the associativity of ordinary multiplication. Okay, number 3, is there an identity element? Yes, the identity element with respect to, take note of our operation, multiplication is 1. Okay, so 1. However, when we check on number 4, do all elements have inverses? Okay, take note. Okay, going back. What does it say here? For every A in G, there should be an identity element. So if I would ask you now, what is the identity element of 0? What is the identity element of 1? What's the identity element of 2? Identity element of 3? Identity element of 4? Again, what did we say about inverse rather? Inverse. Okay? When we say inverse, that which when multiplied to a certain element of G results to the identity element. So bear in mind that the identity element here is 1. Is there a number which when multiplied to 0 gives a product of 1? None. Okay? Because 0 times any number is 0 itself. So ito does not exist. Wala. How about 1? 1 inverse. Okay? So ask this question, what must be multiplied to 1 to get a product of 1? Obviously, it's 1. Okay, so meron. Pero si 2, may inverse kaya si 2? 2 inverse, what number should I multiply to 2 in modulo 5? Take note, we are talking of the set of remainders upon division by 5. Z sub 5. Okay, what is the inverse of 2? Okay, 2 inverse is 3. Yes, because 2 times 3 is 6. And 6 modulo 5 is 1. So meron. Si 2 inverse is 3. Si 3 inverse, okay, 2. Eh si 4 inverse kaya meron ba? 4 times 1. 4 times 0, 0. 4 times 1, 4. 4 times 2, modulo 5 is 3. 4 times 3, 12. Modulo 5 is 2. 4 times 4 is 16. Modulo 5 is 1. So meron din siya. So the inverse of 4 is 4. However, going back to the conditions of a group, for every A in G. So, nasatisfy ba yung number 4? Eh, merong element na walang identity, walang inverse, si 0. Diba? Si 0, walang inverse. Its inverse does not exist. Okay? Therefore, bakit binawi ni Marinel yung sagot niya? Tama ka kanina, 3. You responded 3. Tama. Ito, inverse of 2 in modulo 5 is 3 with respect to multiplication modulo 5. Okay, so, tama. So, property number 4 is not satisfied. Therefore, Z sub 5. Okay, conclusion. Can you see this? Is my screen visible also? You also give me feedback or comment on the screen. Baka minsan lumampas na ako, hindi nyo na mabasa. Z sub 5 under the operation multiplication modulo 5 is not a group. Okay? It's not a group. Kaya from now on, we shall be talking about additive group lang. Additive group. Walang multiplicative group. Kasi nga, inverse of 0 does not exist. Okay, with respect to multiplication. I think that is clear now, so we could move on to subgroups. Okay, your idea of a subset, diba, miyembro, okay, or a part or a portion of the big set, set G. Okay, so when we use G now, we assume that it's already a group. Kaya we often make use of G. A subgroup, okay, by definition, a subgroup of G is a subset of G which forms a group, okay, with respect to the operation defined in G. So a subset of G in which the 4 properties of a group are also satisfied. So a portion of that set, a subset of that set that satisfies the 4 properties. Okay? For example, I think I discussed this last time. Hindi klaro pala, kaya pala tinigil natin last time. The set of even integers forms a subgroup of the additive group of integers. Okay, let's justify. Although I discussed this also in the video which I posted in your Facebook group. I hope you viewed that video. Ito rin yun diniscuss ko na ito dati. Okay, so justifying or checking or verifying whether the set of even integers is a subgroup of the set of integers. So the bigger group here, group na siya. Ano? The group is the set of integers. Okay? The set of integers, and we know for a fact that for the set of integers, the identity element, additive group tayo. So with respect to addition is 0. Okay, how about the set of even integers? So checking on the four properties, is Z sub E close with respect to addition? Or ask yourself, if I add any two even integers, is the result an even integer? Yes, 2 plus 4, 6, 4 plus 6, 10, and so on. So this is an example. 2 plus 4, both are even integers, and the result 6 is an even integer. So closure property is satisfied. Or, in a more general manner, we could denote the set of even integers as 2n. 2n, where n is an integer. Okay, 2n. So if I have 2n sub 1, okay, one even integer plus another even integer, okay, manipulate, get the sum, okay, 2, we have to show that the sum is also of the form 2 times n. Kasi nga, when we say even, it's divisible by 2, yes? It could be expressed into the form 2 times n, where n is an integer. So if I have two even integers, let's say 2n sub 1, okay, and 2n sub 2, get the sum. Okay, how do we get the sum? 2 is common to both, so we could factor it out. There, 2 times n1 plus n2. What did we say? n1 and n2 are integers. Okay, integers. And so the sum of two integers is an integer, n. So I made use of capital letter na to mean the sum of the two integers n1 and n2. So we are very sure that the sum of any two even integers is an even integer because of this factor 2 here, which means closure property is satisfied. Okay, how about associativity? So here is a check. Okay, associativity is satisfied. Identity element is 0. Is 0 an even integer? Yes, because I could express 0 as 2 times 0. So it still follows the form 2n. Okay, now, how about the inverse? Do all elements have inverses? Okay, so let's see. Okay, by the property or inverse, we mean when we take any even integer, add it, okay, to its additive inverse, okay, the result should be the identity element 0. Okay, so 2n plus a raised to negative 1. This is only for us to symbolize or to denote the inverse. So manipulating the equation, inverse is given by negative 2n. So we can rewrite this also as 2 raised to negative n. And what did we say about n here? N here is an integer. So the inverse is also the inverse is also an even integer because of the presence of this factor 2. So that justifies, ay blurred siya. Oo nga no, saglit lang. Saglit lang, i-disconnect ko. Bakit kaya? Blurred pa rin siya? Bakit kaya? Saglit lang. Maliwanag naman siya sa screen ko. Saglit, i-check ko. Okay na ba? Blurred pa rin siya? Or okay na? Sige, try ko magsulat pa ng panibago. Tingnan ko kung blurred. Ito, okay na to? Okay na daw. Okay, sige din. Let's proceed. Okay na. Okay na.
Sa connection nila yan.
Okay. Okay, so going back to the concept of a subgroup. The question is, okay, some of you sent questions to me via Facebook Messenger asking about how to identify the subgroup of a group. Okay, and generators of a group. Yung generator, that's for later, but meantime, let's stick to subgroup muna. How do we identify the subgroup of a group? So for example, Z sub 6 under addition modulo 6. Let me write down a subgroup from here. Okay, let us denote the subgroup to be H. One subgroup here is 0, the group consisting of the elements 0, 3. Okay, 0, 3. Okay, bakit subgroup yan? You might be asking me, bakit subgroup yan? Does it satisfy all the properties of a group? Remember the 4 properties? Okay, closure. Let's check on closure. 3 plus 3 modulo 6 is 0. Nandun yung sagot. 0 plus 3 is 3. Okay? So, closure property is satisfied. Next, associativity. You can check on associativity. I leave it to you. Okay? Let's assume associativity at this point muna. And the number 3, check on the existence of the identity. What's the identity element here? Here, our identity element is 0. Nasa set ba yung 0? Mayroon, nandun, oh. Okay? The identity element 0 is contained in the set H. And fourth property, what's property number 4? Every member of that subgroup, every element of this, okay, should have an inverse. Anong inverse ni 0? What is 0 inverse? Okay, what is 0 inverse? Ask yourself, what must I add to 0 to get 0, which is the identity element 0? Next, ask yourself, what is the inverse of 3? What should I add to 3 in order to get 0, which is the identity element 3? Okay, are these contained in the subgroup or in that small group? In fact, ito sila. So, the 4 properties are satisfied. Closure, associativity, existence of the identity element, and every element of H has an inverse. Okay? And the inverse is contained in H. Therefore, this is a subgroup. This is a subgroup of Z sub 6. So the question is, how do we identify the subgroup? Okay? So, to identify the subgroups, we select. You begin with any element of the given group. Okay? Pick out any element of this group and add it to itself for several times. Then we only stop the moment we end up or we get the identity element. So for example, I would start with 0. Let me start with 0. Of course, when you add 0 to itself for several times, that will give 0 rin, di ba? Next, how about 1? Okay, 1, and then 1 plus 1, 2. 1 plus 1 plus 1, that's 3. Next, 1 plus 1 plus 1 plus 1 4 times, that's 4. Then, 1 plus 1 plus 1 5 times, 5. And 1 plus 1 6 times. You add 1 to itself for 6 times, then that would be 6. But we don't have to write 6 because that corresponds to 0. Because 0 or 6 modulo, okay, this is 5 and this is 0. 6 modulo 6 is 0. What did I say? We stop the moment we get the identity element 0. Okay? How about for 2? Okay, si 2 naman. For 2, continuously add 2 to itself. We begin with 2. 2 plus 2 modulo 6 is 4. 2 plus 2 plus 2, 6 modulo 6 is 0. Okay, so we stop here. Because if I continue, 2 plus 2 plus 2 plus 2 plus 2, that's 8. 8 modulo 6 is 2. We get back to the first element in our list, which is 2. So I will close the set now. Okay? So that's it. Now, let's continue with 3. How about for 3? Again, just like how we generated the previous, we begin with 3 and add 3 to itself for several times. 3. 3 plus 3 is 6. Modulo 6 is 0. Okay, and then 0 plus 3, that gets back to the first element, which is 3. So we stop here. How about 4? Okay, what about 4? 4. Okay, 4. Okay, 4 plus 4. 4 plus 4, that is 8. 8 modulo 6 is 2. And then next, 4 plus 4 plus 4. Walang, Shane, walang 8 anak kasi Z sub 6 lang tayo hanggang 5 lang. Okay, remainders tayo. So, hindi dapat lalagpas ng 6. Okay, 480. Luisa also. Okay, take note that this is our set. 0, 1, 2, 3, 4, 5. The remainder. So, pag 8, anong remainder? When we divide 8 by 6, remainder 2. Kaya balik tayo ng 2. You get it? Okay, so please be ayan, 4, 2, 0. So, you got it. And then, 4 plus 4 plus 4, 3 times you add 4 to itself, that's 12, yes? And 12 modulo 6 is 0. Okay, so, any question at this point? Klaro ito kung paano nakuha. Now, what about 5? I hope all of you can follow. Okay, about 5. So, we begin with 5 and then add 5 to itself. 5 plus 5 is 10. 10 modulo 6 is 4. Next, add 5 to itself 3 times. Or 5 times 3, that's the same as 5 times 3, yes? 15 modulo 6. Okay, 15 modulo. Okay, Crizel, Marnel, and Crizel said 5 for 3. Angelica also, 5 for 3. 2, 1, and 0. Okay? So, looking at what we have generated, how many subgroups have we generated from here? Okay? Let this be, is this a subgroup? This is a question. Is this group consisting of the identity element a subgroup? Does it satisfy the 4 properties? Okay, 0 plus 0, 0. Closure property is satisfied. Associativity is satisfied. Identity element, ito nga siya, si identity element. Anong inverse ni 0? 0. So, it's a group. Okay, this is a group. How about the second? This is the original group, diba? In fact, 1, the element 1 generated the original group. Kasi nga, lahat yan. 1, 2, 3, 4, 5, 0 are members of this set. Okay, our original set. Trivial. Dexter said trivial. Okay? So, si first at second, ang tawag dyan ay trivial subgroups. Okay? Trivial subgroups. So, how many subgroups have we generated? 1, 2, 3, 4. 4 lang, di ba? Because that one generated by 1 and that generated by 5 are the same. Okay? That generated by 4 and that one generated by 2 are also the same. So, Joel answered 4 subgroups. Correct. Ay, ba't nyo dinelit yung mga sagot nyo? Crizel, Marnel, and Luisa. Okay naman, tama. 4 subgroups. And then we have another. Bilis nyo mag-erase ng sagot nyo. Tama naman. Okay? And then here, eto. Okay, so 4 subgroups. Are we sure that they are subgroups? Yes. Okay? Yes. So, 0, ito, let me use the red. These are the trivial subgroups. Okay, the trivial subgroups. So, what do we mean by trivial subgroups? that group which contains the identity element, ito yun, that group which contains the identity element and the group itself are the trivial subgroups of a group. And the other group subgroups generated are that which is generated by 2, generated by 3, but 2 and 4 generates the same subgroup. Okay? So this is how to form the subgroup of a group. Are there questions here? I hope this is clear. Okay? Next, we move on to the next. Okay na tayo? We move on to the next. Some theorems and corollaries on subgroup. Theorem 1 says, if H is any subgroup of a group G, then the identity element of G, okay, of the bigger group, yung identity element daw ni G ay nasa H. And in fact, ito rin yung identity element ni H. True enough, if you go back to this subgroup, for instance, okay, I want you to pay attention to this subgroup, okay, 2, 4, 0. The identity element 0 is in the subgroup. And in fact, this is also the identity element of the subgroup generated by 2. Okay, so that's theorem number 1. Another theorem says, a subset H of group G is a subgroup if and only if the following are satisfied. H is not empty set. Okay? It's not a null set. It's not an empty set. And for every pair of elements A and B in H, the product of A times B inverse is an element of H. The product of, let me write that down, the product of A times B inverse is in H. So for example, let's consider 2 and 4. 2, okay, 2 plus, okay, 4 inverse. Sorry. Okay, 4 inverse. Is this an element of, should be an element of the subgroup? What does it mean by this? 2 plus, okay, what's the additive inverse of 4? Ano yung additive inverse of 4 sa Z sub 6? Ano yung additive inverse of 4 in Z sub 6? Okay? Ask yourself, what should I add to 4 in order to get 0? Kasi ito yung identity element natin, di ba? What should I add to 4 in order to get 0? It's 2. Okay? So, the identity element of, or sorry, the inverse rather. Why do I keep saying identity? The inverse of 4. In the inverse of 4 with respect to addition modulo 6 is 2. Or, what is that number which when added to 4 in modulo 6 results to 0? Edi 2. Okay. So, plus 2 modulo 6. What is this equal to? It's 4, isn't it? Is 4 an element of H? Okay, nandun siya. Yan, no? Element of H. So, that's it. It's not an empty set. Not an empty set. And for every pair of elements A, B, and H, the product AB is an element of A times B inverse rather is an element of H. Are there questions here? Questions? Pabilisan natin, no, para makarami tayo. Next, every group has a unique identity element. Nakita naman ninyo yun, isa lang. So, in the previous example, the identity element is 0, nothing else. And since a subgroup is a group, it must have an identity. Next, every group has at least 2 subgroups. Okay, at least 2. Kasi meron na tayong trivial subgroups, di ba? 0, or should I say that group consisting of the identity element and the group itself. Yun yung, yan. The group itself and that which contains the identity element. I made use of E just to mean identity element, but in the previous example, it's 0. Okay? Next. Identify all the subgroups of Z sub 12 under modulo addition. May I skip this portion na? If it's all right with you, can we skip this na so we could move on to the next? Can you do this by yourself na lang for your exercise? This problem number 1 here. It's similar to the previous example anyway. So all you have to do is to take each element of Z sub 12 and generate the subgroups. Okay? So we proceed to the next. Ay, tapos na tayo dyan. Ito, problem number 3. Okay? Find the subgroups of the group S sub 3. Can you remember S sub 3? That permutation group? Okay, the permutation group. S sub 3, set of permutations on 3 symbols or on 3 letters, on 3 numbers. Arrangement, remember? But we made use of different Greek symbols dun kasi. But meantime, may we use alpha, beta, gamma, delta, phi, and rho. And the table is already available. Nandito naman na siya. It's similar to the table which we have generated last time when we discussed permutation. Or I think this is your assignment, di ba? Permutation of 3 symbols. Okay? So this is the result. And what's the operation? Composition. Okay? And may I use circle to denote the operation? Composition. What are we going to do? We are to find out the subgroups of S sub 3. Ano kaya yung mga subgroups ni S sub 3? Permutations on 3 symbols. So let's, answer this together. Okay, so let's go back. We need this table for us to generate the subgroups. Remember how we generated the subgroup of the additive group Z sub 6? We added or we pick out one element of Z sub 6 and operate it unto itself for several times. For the previous example, the operation is addition modulo 6. But here, our operation is the composition of functions. Composition. So, let's list down first the elements of our group. Instead of S sub 3, I will be using G muna to mean that it's a group. Because in the previous discussion anyway, we have verified that this is a group. Kaya nga ang tawag natin ay permutation group. So, set G consists of the elements alpha, beta, na yun. Let's insert natin yung image. Klaro ba siya? Nakikita nyo? Kita nyo yan? Okay, so alpha, beta, gamma, delta, phi, and rho. Okay, so how do we generate the groups or subgroups of this permutation group? Like what we did in the previous, you select one element and operate it to itself for several times. So let's start with alpha. If I pick out alpha, we begin with alpha. What will alpha, circle alpha be? Alpha times alpha, or alpha raised to 1 is alpha itself. What would alpha squared mean? What does it mean by this? Alpha, circle alpha, what will that be? Ito, look at your table. Yan, alpha times alpha is alpha. Walang ibang ma-generate na Okay, walang ibang ma-generate na element kundi alpha. So we stop with this. Next, how about the next element, beta? Okay, let's take beta. What is beta raised to 1? Beta squared, beta cubed, and so on. So beta raised to 1 is beta itself. What about beta circle beta? What is it equal to? Beta circle beta, look at your table. Beta circle beta is alpha. Okay? So this one is equal to alpha. So should we continue? Should we continue with b cubed? Or beta to the third power? What did I say a while ago? Nung z sub 6 tayo, we stop the moment we obtain the identity element already. Remember that for your permutation of set of permutation, your identity element is alpha. Or yung arrangement na 1, 2, 3, 1, 2, 3. Okay, go back. Ito yon. Ito yung identity element natin last time. Yes, ito. This is the identity element with respect to your set of permutations on 3 symbols or alpha. So put that in mind, our identity element here is alpha. Okay? Alpha. Okay, so we will not proceed with this anymore because for sure this will, yan, okay? So the set that we have generated here, by the way, is simply alpha. Ito sa pangalawa, we have generated beta and alpha. How about the next? Take delta or gamma. Okay, for gamma, gamma raised to 1, gamma squared, gamma cube. Hanggang cube muna tayo, we'll see. Okay, gamma raised to 1 is gamma itself. Gamma squared means gamma, circle gamma. What is it equal to? Yan, gamma, circle gamma. Gamma, circle gamma is equal to alpha. Okay? Gamma, circle gamma is alpha. So, we stop with this also. Equal to alpha. Okay, so let me write it down. Okay, gamma, alpha. Next, let me erase this now. Next, gamma, alpha. Yung delta. Si delta kaya. How about that which is generated by delta? So, delta raised to 1, delta squared, delta cubed, and so on. Delta, okay. How about delta circle delta? Delta circle delta, what is it equal to? From the table, delta circle delta is phi. Phi. So, we should not stop here kasi hindi pa naman yan yung identity element. So, we continue. So, delta, circle delta, what will this be? So, phi na yung kanina, ano? Diba ito, phi? Delta, circle delta is phi. Okay, circle delta. Phi, circle delta is alpha. Okay? So, alpha, delta, and alpha. So, we end up with this. Did you get that? Okay, so, now we have delta, phi, and alpha. Next, how about phi? Phi, okay, phi raised to 1, phi squared. Phi raised to 1 muna tayo. Phi circle phi, what is it equal to? What is phi circle phi? Delta phi alpha. Okay, tama sila. Delta phi alpha, delta phi alpha. How about for phi? Phi circle phi, look at your table. Phi circle phi is delta. Some pronounce it as phi, so it's up to you. You can use phi, okay, phi. We usually encounter this in physics, yes? Okay, so once more. Phi circle phi. So, bakit yun ang ginamit ko? Okay. Phi circle phi is delta. Okay, delta. Next, phi cube. What is phi cube? Means phi times circle phi. Circle phi, what is it equal to? Delta circle phi. Delta circle phi is alpha. Okay? Phi delta alpha, Erica said. Phi delta alpha, phi delta alpha, phi delta alpha. Okay, I think you got the right answer. Okay, so we have generated the subgroup phi, delta, and alpha. How about the last one, rho? Si rho kaya? Rho. Okay, rho raised to 1, what is it equal to? Rho squared, what will this be? Rho cube, what will this be? Okay, so for rho, this is rho. Rho times rho. Rho times rho is alpha. So we stop with this. Okay, so I'll erase this now and this is equal to alpha. Therefore, we have generated the set. Okay. Now, how sure are you? Rho alpha, rho alpha. Okay, so you got it right. Are they really subgroups? O check, anong sabi natin? The identity element of the group must be in H. So, isa-isahin natin. Ayan, nandyan si identity element. Nandito si identity element, nandyan si identity element, nandyan si identity element. Okay? And you take any two elements of the subgroup, A times the inverse of the second element must be in H. Okay? So, looking for example at this subgroup. If let's check on the second condition. Remember the second condition here? Pakita ko lang para maalala nyo. Yung condition number 2, for every pair of AB, A times B inverse should be in H. Okay? A times B inverse, A times the inverse of the second must be in H. So let's go back to that. Ito. I will get this group. I'll get this group, delta phi alpha. So wag kalimutan. So let that be H. One group is delta, phi, and alpha. Okay? So, is the identity element of G in H? Answer, yes. And in fact, E is equal to alpha. There it is. Next, this is the first condition. Remember, this is the first condition. Condition number 2. Okay, for every AB, which is an element of H, then dapat A circle B inverse must be in H. So let's check. Okay, is delta circle phi inverse an element? Okay, an element of H. An element of H. Is it an element of H? What is phi inverse? So let's go back to the table. Okay? Remember that our identity element is alpha. Okay? Phi inverse, ano inverse ni phi? So, when we ask about inverse, hanapin mo sa table yung ang sagot ay alpha. Kasi when we multiply phi to its inverse, the result should be the identity element which is alpha. Okay, to si alpha. So if I would ask you, basing from here, can you identify the following? Ano ang inverse ni alpha? Anong inverse ni beta? Anong inverse ni gamma? Okay, what's the inverse of delta? What's the inverse para masagot natin yung second condition and yung inverse ni rho? Okay? Remember, our identity element is alpha. Okay? So, when you operate this specific element with the inverse, the result should be the identity element alpha. So, look at your table. What must be multiplied to alpha in order to get this product? Alpha, si alpha. So, the inverse of alpha is alpha itself. Next, how about the inverse of beta? Anong inverse ni beta? Hanapin nyo sa table, along this row, si alpha. Okay, anong minultiply kay beta para ang sagot or product is alpha? Si beta. Parang assignment nyo to, sinagot ko na ah. Okay, next, gamma inverse. Gamma, so this is gamma. Okay, gamma. Hanapin mo si alpha. Yan. Anong minultiply kay gamma para ang result ay alpha? Si gamma. Okay? So, I'll be writing here gamma. What's the inverse of delta? Okay, for delta, the inverse is, ayan, dyan tayo nagkaiba. The inverse of delta, yan, the inverse of delta, what must be multiplied to delta in order to get a product of alpha? It's phi. Okay, so it's phi. Crizel said phi. You're right. So, phi. Okay. Phi or phi. Next, how about inverse of phi? Inverse of phi, what must be multiplied to phi in order to get alpha? Nagkabaligtaran. Ano? Si delta. Okay? So, here, delta. And finally, rho. What must be multiplied to rho in order to get a product of alpha? It's rho itself. Okay? So, rho. So, let's go back. So, we're done with condition number. What are we trying to do? Checking whether those that we have generated are really subgroups of the set of permutations of three symbols. So, going back, huwag kalimutan na ang inverse ni phi ay delta. Put that in mind, okay? Inverse of phi is delta. So, let's go back to our solution a while ago. Okay. Inverse of this is delta. So, what is delta circle delta? Okay, go back to your table. What is delta circle delta? Ayan. Delta circle delta is, okay, delta circle delta is phi. Okay, so we have shown that the result here is phi. The answer here is in fact phi, and which is found in the subgroup. Nandito siya eh. It's an element of H. Okay? So, it's an element of H. Therefore, this is a subgroup. So, that's it. So, it satisfies the two conditions. You take any two pairs, okay? You take any two pairs, okay, of elements of H. Should satisfy the condition A times, okay, the inverse of the second is in H. And that's it. Okay? Are there questions at this point? So I hope I answered your question on how to form the subgroup. Questions so far? Wala. So we proceed to the next. Okay, we move on to the next. Questions at this point? Are there questions at this point? Wala naman. So we could proceed to the next. If there are no questions, let me see kung may mga tanong muna before we proceed. Wala naman. Okay, so wala. None so far. Okay. Next. We now move on to the next theorem, another theorem on subgroup. If A is an element of G, then H is equal to, ayan, this is how we generated the subgroups a while ago. A raised to K, where K is an element of the set of integers. Then the group is a subgroup of G. So remember how we generated the subgroups of Z sub 6? Take one element and raise it to K, raise it to K. So 1 raised to 1, 1 raised to 2, na depending upon the operation. So additive group yun, kaya 1 squared means 1 plus 1. 1 cubed means 1 plus 1 plus 1. Okay? E yung kaninang example natin is permutation group, the operation is composition. Kaya when we say beta cube, that means beta, circle beta, circle beta. Okay? Now we proceed to the next. What about this? Order of an element. What do we mean by this? This refers to the number of elements in the subgroup generated by that element. Number of elements in the subgroup generated by that element. So let's go back to our solution a while ago. Ito. By the way, this is how we denote, or we can write this properly as, let me just add, okay, so kita pa rin ba sa baba? Ito has, okay, generates 0. Now, I'm using the word generate na. So, to give you an idea of a generator of a group. Okay? The order of 1, so if I ask you now, what is the order? What is the order of 0? What is the order of 0? 1. Next, order of 1, okay, 1 generates the following. Okay, 1, 2, 3, 4, 5, and identity element 0. So if I say order of 1, what is it equal to? Order of 1, number of elements in that subgroup generated by that element by 1, then the order must be, okay, you're right, 6. So that's how simple it is. Order of a group. So if I would ask you now, what is the order of this group? Or of 2? What is order of 2? 3. What is the order of 3? 2. What's the order of 4? Okay, the order of 4 is 3. Order of 5 is 6. So that's it. Let's go back to that slide on order of an element. So that's it. When we speak then of order of an element, just have to remember that it refers to the number of elements in the subgroup generated by that specific element. Okay? Now, we move on to groups, cyclic groups. Now, by definition, cyclic group, a group G is cyclic if and only if. Okay? When is it cyclic? If and only if there exists an element A in G such that G could be generated by A raised to K, where K is any integer. Okay? The element A is called the generator of the group G. A is the generator. So, balikan natin si Z sub 6. Ano kaya yung elements na makapag-generate sa lahat ng elements ni Z sub 6? Maalala nyo? So, balikan natin si Z sub 6 ulit para makita nyo ang konsepto ng generator. Ayan. Ano yung elements? May element ba? May element ba si Z sub 6 na makapag-generate sa lahat ng kanyang elements? Meron, di ba? Anong elements yun? Let me put, okay, an asterisk on. Okay, good. Jaisel and Marnell said 1 and 5. Correct. 1 and 5. They are called generators. Okay? And therefore, since Z sub 6 has generators, then it is considered a cyclic group. You got it? Okay, so this is an example of a cyclic group. Let's go back to that slide on cyclic group. Klaro yun? Klaro? Ayan. So, a group G is cyclic if and only if there exists an element A in G such that G could be obtained by A raised to K, where K is any integer. So, an example is Z sub 6, additive group Z sub 6. Next, the element A is called the generator. So, if I would ask you what are the generators of Z sub 6? Which elements generate Z sub 6? The generators are, you said it, 1 and 5. 1 and 5. A cyclic group may either be finite or infinite. Theorem: if a cyclic group G with generator A has order n, then A to the n is equal to E. Tama kaya yun? Tingnan natin, A to the n. Finite group ito, yung ating Z sub 6 kanina. Balik-balikan lang natin si Z sub 6 kasi simple lang naman siya. Okay? A to the n is the identity element. Tama naman because this one here is, okay, 1 here is 1 raised to 1. 2 here is 1 raised to 2. 3 here is 1 raised to 3. 4 here, 1 raised to 4. 1 raised to 5. And 0 is 1 raised to 6. Because 1 raised to 6 means 1 plus 1 plus 1 plus 1 plus 1. 6 times is 6 yun. 6 modulo 6 is 0. Tama. Okay? So, anong sabi kanina nung theorem? Balikan natin si theorem. Medyo mabilis na tayo. Ayan. The theorem says, if a cyclic group with generator A has an order n, then A raised to n is equal to E. Okay? So, the group K has an order n, A raised to n, 1 raised to 6. Okay, order of 1 is 6, remember? A raised to n gives the identity element. And the distinct elements of G are A squared, A cubed, until A to the n, which gives the identity element. Questions so far? Ba't ni-restrict niyo ulit yung sagot niyo, Felicio and Marnel? Tama naman. Tama naman kayo. Next, definition. If A is an element of a group G, the order of A is defined to be the order of the cyclic subgroup of G which has a generator. Okay, I think we mentioned this already a while ago. The order of an element may also be defined as the smallest positive integer n such that A to the n is equal to E. Okay? If no such n exists, the order of A is infinite. Okay? If this does not exist, if no such n exists, the order of A is infinite. Okay? Next. Now we consider another set, the set Z sub 8, whose elements are 0, 1, 2, 3, 4, 5, 6, 7, operation, addition, modulo 8. The group is cyclic because the following are generators of the group: 1, 3, 5, and 7. The group is cyclic with generators 1, 3, 5, and 7. The order of 1 is 8. The order of 2 has an order 4. 3 has order 8. 4 has order 2. 5 has order 8. And so on. So, ipakita na lang natin para hindi kayo mag-i-imagine. Ano? Okay? So, Z sub. Ayan, Z sub 8. Okay, so Z sub 8 has the elements 0, 1, 2, 3, 4, 5, 6, and 7. So, 1 generates, okay, 1 generates what set? 1 generates, or 0 rather, 0 generates 0, wala nang iba. How about 1? 1 generates all, diba? Because 1, okay, 1 raised to 1, 1, 1 raised to 2, 2, 1, 2, 3, 4, 5, 6, 7, and 1 raised to 8. 1 raised to 8 means add 1 to itself for 8 times. That's the same as 8 times 1 is 8 modulo 8 is 0. Okay, that's the identity element. Next, how about 2? For 2, we have what will be generated by 2? 2, 4, 6, and 0. Okay? 2, 4, 6, 0. 2, 4, 6, 0. 2, 4, 6. Okay, you're right. Next, how about 3? What will be generated by 3? 3, 6, okay, 1. Tama? 3, 6. Bakit 1? Tama. 3 plus 3, 6. Okay? 6 plus 3, 9. Modulo 8, 1. 5. Okay, plus 3. Can you follow? Ito, this is from 3 raised to 1. This one is 3 squared. This one is 3 cubed. Okay, 3 cubed. Remember, our operation is addition modulo 8. So, hindi ito times, Okay, so 5 here is 3 to the 4th means, okay, 3, 6, 1. Sorry, bakit 5 ito? 4. This should be 4. Let's, once more. Okay, 3. 6. Okay, 1. Ito, this came from 3 raised to 1. This came from 3 raised to 2. This one from 3 cubed, that's 9. And then this one from 3 to the 4th, 12. Modulo 8 is 4. And then we have 3 to the 5th. Okay, modulo. What's that? Okay, you're right. 3, 4, 7, tama. And then, this is from 3 raised to 6. That's 18. 18 modulo. Correct. 18 modulo 8 is, because that's 18 minus 16 is 2. Then this is 3 raised to 7. And then we'll end up with 3 raised to 8. Okay. 3 raised to 7 is, okay, you're right. Because that's 21 modulo 6, 21 modulo 8. That's 21 minus 16 is 5. You're right. And this is finally 24. 24 modulo 8 is 0. Okay, so correct. You got it all. Next, how about for 4? For 4, we have 4 and 0. Wala na, di ba? 4 and 0, correct? Next, for 5. What about for 5? For 5, we have, okay, 5, 2. What about 5? Okay, 5 plus 5, 10. 10, 15 is 7, correct? 15, 20 is 4. 25, 1. Correct? Okay, and then we have 30 is 6, and then 32, 3, and then 40, 0. Okay, that's it. Next, how about for 6? 6 and then 12. 12 modulo 8 is 4. Bakit ito? Bakit yung 2? Hindi natin natapos yung 2. 0 ito. Okay? 6, 4, 2, and then plus 6, 0. Okay? Next, 7. For 7, we have 7. Is 7 a generator? 7 plus 7, 14. Diba? 14 modulo 8 is 6. 21 modulo 8 is 5. Then 4, 3, 2, 1, and 0. Okay? Okay, that's it. So, if I would ask you now, which elements are the generators? Okay, what are the generators of Z sub 8, addition modulo 8? The generators are, what are the generators? We have the following generators. 1, ayan, lagyan natin ng asterisk C. 1, 3, 5, 7. Okay, so ang mga elements na to nagde-generate nung group 1, 3, 5, and 7. You're right. Okay, so if I would ask you now what's the order of 1, the order of 1 is 8. The order of 3, 8. The order of 5, 8. The order of 7 is 8. The order of a generator is n, referring to number of elements. So let's go back to that slide. Anong sabi nung previous slide? Ayan. So tingnan natin kung tama. The group is cyclic with generators 1, 3, 5, 7. The order of 1 is 8. Okay, tama ba? Order of 1 is 8. Tama naman. The order of 1 is 8. Okay? The order of 2 is 4. Tingnan nga natin. The order of 2 is 4. Tama. Order of 2 is 4. Order of 3 is 8. The order of 4 is 2. Order of 5 is 8. Order of 6 is 4. Order of 7 is 8. Okay? So that's it. Are there questions at this point? So is this a cyclic group? Yes, with generators 1, 3, 5, 7. Next. In the group of symmetries of the square, R sub O, okay, did you watch that video on set of symmetries of a square? Motions on the plane, R sub O, R0 has an order 1, R1 order 4, R2 has order 2, R3 has order 4, X, Y, D1, D2 all have order 2. Okay, the Lagrange Theorem, nandito rin tayo. Tapusin na lang muna natin hanggang dito. Okay, so that by next week, expect for a long quiz on this. So, 2 quizzes na lang. Separate na lang natin yung permutation group at saka yung itong discussion ngayong morning. What time is it? Time check, 10:43. Okay, Lagrange theorem says if H is a subgroup of a finite group G, then the order of H is a divisor of the order of G. Once more, if H is a subgroup, then order of H is a divisor of the order of G. So let's look at our previous example then. Okay. This one has an order of, where are the subgroups here? Ito yung mga subgroups. Okay. Ito subgroup, trivial. Ito trivial itong mga to. Okay. So the other subgroups are, we have that which is generated by 2, ito. And then, nothing else. Diba? Dalawa lang. So the subgroups here are, apart from the trivial subgroup, I won't be writing the trivial subgroups na, just the groups na lang, subgroups rather. Let H1 be the subgroup consisting of 2, 4, 6, 0, and then H2, subgroup number 2 will be 4, 0, nothing more. And of course, your trivial, okay, trivial subgroups, which is, let's say, H3 or, plus your trivial subgroups na lang. Plus the trivial subgroups, eto, this, and the group itself. Okay? And the group itself. So, going back to the Lagrange theorem, what does it say? about the order of the subgroup and the group. The order of the subgroup is a divisor of the order of the group. Okay, what's the order of this group? Remember, order refers to number of elements. Order is 8. Okay? The subgroup here, generated by 2, has an order of 4. Diba? The order is 4, and 4 is a divisor of 8. 4 divides 8. This subgroup, generated by 4, okay, has an order of 2, and 2 is a divisor of, okay, of 8. So 4 here divides 8, 2 divides 8. So do not expect then for a subgroup having 3 elements. Wala. Kasi sabi ni Lagrange Theorem, ito let me underscore, if H is a subgroup of a finite group G, then the order of H, number of elements daw ni H, is a divisor of the order of G. Okay? The number of elements of H is a divisor of the order of the group. So, going back once again, here, the order of the group is 8. So, anong expectations natin? The subgroup, that the subgroup may contain, okay, 1 element, 2 elements, 4 elements, and 8 elements, because those are the only divisors of 8. So, let me write that down. If we jot down the divisors of 8, what are they? Ito yung mga divisors ng 8, diba? Divisors of 8 are 1, 2, 4, and 8. So, anong expectation? Yung subgroups may contain, the subgroup may contain 1 element, 2 elements, 4 elements, or 8 elements. Ito at saka ito, yun yung trivial subgroup natin. True enough, ano yung mga subgroup na na-generate natin? This one, order 2. And this one, order 4. Is that understood? Okay, I hope you understood that. That's the essence of the Lagrange Theorem. Other questions here? So if I would ask you now, if I would ask you to identify, okay, the subgroups of Z sub 12. Okay, so going back to Z sub 12, although hindi natin sinagutan, ano yung mga posibleng order of the subgroups ng Z sub 12? Merong subgroup na may isang element, may 2 elements, may 3 elements, may 4 na elements, may 6 na elements, at may 12 na elements. Pero, never will we get a subgroup with 5 elements. Okay? So, in like manner, for Z sub 8, never will we generate, never will we generate a subgroup with 5 elements. O, tingnan natin yung subgroup ng Z sub 8. Yan. Okay? Ay yung Z sub 6 kanina, balikan ulit natin si Z sub 6 para lang ma-confirm ito. Okay, so for Z sub 6, ito, order of 2 is, okay, the order of 2 here is 3. Does 3 divide 6? Z sub 6 tayo. Okay, does 3 divide 6? Yes. Ito, the order of 3 is 2. Does 2 divide 6? Yes. Here, the order of 4 is 3. Okay? So, walang subgroup na may 5 elements. Walang subgroup na may 4 elements because also 4 does not divide 6. Next. Some other corollaries. If the order of a group G is a prime number P, then G is cyclic, and every element of G other than the identity element is the generator of G. Okay? Tama kaya yan? Yes, i-check natin with Z sub 5. Okay. Sabi niya, if, okay, Let's go back to that. Bakit assessment task na tayo? Ito, sa corollary tayo. Say, the first corollary says, if the order of a group is prime number P, then G is cyclic, and every element of G other than the identity element is a generator of G. Other than the identity element, meaning all other elements are generators of G. Quick example, okay? Just one quick example to illustrate this is Z sub 5. So Z sub 5 has the elements 1, 0, 1, 2, 3, and 4 under addition modulo 5. Okay? What the group generated by 0 is 0. Group generated by 1 is, okay, the group itself, 3, 4, 0. And then the group generated by 2 is, look, 2, 4, 1, 3, okay, 0. Bakit yun? 2 plus 2. Okay, 2 plus 2, 4 plus 2, 6 modulo 5, 1. Okay? Okay, and so on and so forth. How about 3? That which is generated by 3 is 3. 3 plus 3, 6 modulo 1. And then 4. Okay? And then plus 3, 7, 2. And then plus 3, 0. Okay? Next, finally, 4. Okay, 4 plus 4, 8. Modulo 5 is 3. Okay? 2, 1, and 0. That's it. So, see, okay, every element generates the group. What did we say? If this is prime. If, okay, the order of Z sub 5 is here, the order is, let's let the order be n. Okay, the order here is 5. And it is prime. The first corollary says, if the order of a group is prime number, then G is cyclic, and every element other than the identity is a generator of G. So, all elements, okay, except the identity element generates the group. I hope you understood that. Now, we move on to the next. If the order of the group is the integer n, then for every element A in G, A raised to n is equal to E, where E is the identity element of G. Tama nga naman. Ito, look at this. Okay? This one came from this 0 here, came from 1 raised to, the order is 5. 1 raised to 5. This came from 2 raised to 5. Okay, 2 raised to 5 is 10. Okay, 10 modulo 5 is 0. This came from 3 modulo 5. 15 modulo 5 is 0. This came from 4 raised to 5. Okay, so that's the essence of the second corollary. It says, if the order of a group G is the integer n, then for every element A in G, A raised to n is equal to E is the identity element of G. Next, the order of every element of a finite group is a divisor of the group order. Okay, it's a divisor of the order of the group. Other questions at this point? Naintindihan nyo naman. So, A raised to, sabi dito, that A raised to n gives the identity element. Meron pa tayong isang topic eh. Okay? Yung cosets, although we discuss naman na yung na-touch natin konti yung Lagrange Theorem, ito hindi pa natin natapos ito. Ito in passing na lang. Ito na-mention na natin to, trivial subgroup, all other groups are non-trivial. So as fast as we could na lang. Then cyclic group, what did we say? If there is an element of G that could generate all the elements of G, then it is a cyclic group. Okay? If G could be generated by this A raised to K, where K is an integer. Next, generator, element that generates G. If A generates G, okay? A group G is cyclic if there is some element in A that generates G. Ulit-ulit na yan. Now, let G be a group. Okay, ito na yan. Ito siya, yung ating mga generators. So, what are the generators of Z sub 6, 1, and 5? I hope I answered your question on generator. Is it clear now? Okay, next. Example, generators of Z sub 7. What do you think? What do you think are the generators of Z sub 7? I want you to pay attention to this. For Z sub 6, okay, the generators are, for Z sub 6, the generators are, can you remember? 1 and 5. Diba? 1 and 5. For Z sub 8, can you remember? You answered a while ago. 1, 3, 5, 7. Okay? For Z sub 5 kanina, the generators are all elements except 0. 1, 2, 3, and 4. So, if we have Z sub 7, can you predict what are the generators of Z sub 7 even without actually listing down the subgroups? What do you think? Joel said 1, 2, 3, 4, 5, and 6. Bakit? Bakit kaya? Jaisel also said 1, 2, 3, 4, 5, and 6. So, for Z sub 9 kaya, ano kaya yung mga makagenerate ng Z sub 9? Okay? Z sub 9, can you tell me which elements will generate Z sub 9? It will be 1, 2, 3. Kasama si 3. 1, 2, 4, 5, 7, and 8. For Z sub 9. 1, 3, and 9? 1, 3, and 9? You sure? 1, 2, 4, 5, 7, and 8. So, para obvious na, kapag Z sub 3, what will generate Z sub 3? Sige nga, Z sub 3, di ba? Si 1, kasi 1, 2, 0. Okay? Si 2, 2, okay? 1, and 0, di ba? Nothing more, kasi Z sub 3, tatlo lang elements niya. So, bakit equal sign? Sorry, please do not use equal sign dito. This is for Z sub Z sub 5, the generators are 1. And this is for Z sub 7. And then for Z sub 3, what are the generators then? Ito, clearly 1 and 2 are generators. So, what can you say then? What can you say about generator in relation to the order? Okay, in relation to the order, any observation? In relation to the order? What made you say that these elements will generate Z sub 9? What made you say that these elements will generate Z sub 9? Somebody mentioned about prime, Norlin? Yes. Okay, so let me just write it down then. If n is prime, all elements except the identity element are generators. Okay? Are generators. Or all non-zero elements are generators. Is this visible? Nababasa niyo yung red or hindi? Nababasa niyo yung red or hindi? Tingnan ko muna sa monitor ko kung nababasa. If it is prime, ma'am, lahat kasali. Okay, lahat kasali except 0. Tama? Pag hindi prime, sabi ni Dexter, relatively prime. Okay? So, if n is composite means more than 2 factors, ano? Okay? All elements that are relatively prime to n are generators. Ay, ala, no daw, hindi mabasa. Sorry, sulat ko na lang. Sulat natin. Importante pa naman ito. Okay, so for generators, for Z sub 6, the generators are 1, 3, 1 and 5. Sorry. 1 and 5. Correct? One and 5. For Z sub 8, we have 1, 3, 5, 7. For Z sub 9, we have the generators 1, 4, 5, 7, and 8. For Z sub 5, the generators are 1, 2, 3, and 4. For Z sub 7, the generators are 1, 2, 3, 4, 5, 6. For Z sub 3, we have 1 and 2. Okay, so what did we say? If n is composite, all elements that are relatively prime to n are generators. Relatively prime. For example, ito. 5 and 6, what is their common factor? 1. 7 and 8, common factor? 1. Bakit hindi in-include si 4? 4 and 8 share a common factor, which is 4. Okay, 1, 4, 5, 7, 8, 4, Z sub 9. And when n is prime, all, okay, non-zero elements are generators. Or all elements except the identity element. You got that? Did you get this? Okay. So, for example, number 3, theorem. Ito na, I leave this to you na lang. Tapos naman na natin yan. Now, every cyclic group is abelian. Okay? Abelian group. Remember abelian? Commutative property holds. Commutativity holds if it is an abelian group. Every subgroup of a cyclic group is cyclic. Okay? Ito na siya. The numbers 1, 3, 5, 7, okay, are relatively prime to 16. So these are the generators. As fast as we could na. Okay, for your assignment, answer example number 3, example number 5. That's it for now. Okay, example number 3 and example number 5. I still have one topic left with you on cosets, Lagrange Theorem, quotient group, and homomorphisms. I hope you understood the lesson for this morning on forming the subgroup, identifying the generators of a group, order of a group, again, cyclic, identifying whether a group is cyclic or not. Questions at this point? Okay, so please prepare for a quiz next meeting. And we will try to cover all of the remaining topics also for next meeting, which is on the following: cosets, Lagrange Theorem, and rings pala. Meron akong hindi include dito, and rings. Okay, so to complete part 2, okay, complete the module. Questions so far? Yung ito, na-post ko na ito sa lens. Okay, nasa lens na ito. Tapos yung ito, yung may solutions tayo, may mga notes ako. Itong mga notes ko, i-upload ko na lang sa lens para may guide kayo pag mag-review kayo. Okay? So if there are no questions, then we could end up the session now. If there are some other questions which you would like to ask from me, just feel free to send me a message. Okay? Okay, bye everyone. Thank you for joining me this morning. I hope you learned something from our session this morning. Bye and thanks everyone.